Okie doke, we're going to look over polynomial work. I just posted the polynomial test, study guide for polynomial test. I'm only going to go over a handful of things today. Here are the things that I'm going to go over. Number one, combining like terms, like numbers 1 and 2. Combining like terms, adding and subtracting polynomials. Pretty simple. You should have that in your back pocket. That one should be pretty easy. The second thing I'm going to go over is like numbers 2, 3, and 4. It's multiplication and the distributive method. Again, you should have that in your back pocket for numbers 1, 2, and 3. Now, number 4, 5, and 6, and sort of number 7 step into the FOIL method, multiplying binomials, okay? First thing that we've got to go over, monomial. A monomial is just a single expression, like 3. That is a monomial. How about just x? That is a monomial, okay? How about just 3 times x? That is also a monomial. Also, x divided by 3, monomial. The only way that it couldn't work with division is if the variable was on the bottom. Can't have a variable on the bottom because you may get 0 on the bottom, and we all know, hopefully we all know, you can't divide by 0. 0 does not work. It's undefined. But these are all monomials. Anything separated, like a variable's expression. How about this? 3xy to the second. Is that a monomial? Yes, it is a monomial. It's all just 1. There's no addition or subtraction. That's what creates the bi, 2 or trinomial. Okay? Okay, binomials and trinomials. Binomials would be something like this. 3x plus 2. That's a binomial. 2 monomials. How about 3x squared plus 2x plus 3? That's a trinomial. 1, 2, 3 monomials. Okay, making sense? All good with that? Now that you know the basics of monomial, binomial, trinomial, I'm going to have to erase right now, so bear with me. It's going to be interesting. You're going to get a close-up view of my desk. Way too close for you to be able to see anything, so I'll make it quick. It might not be the greatest erasing. There we go. All right. Simplifying a monomial or binomial or trinomial expression like number 1, if you have 3x squared plus 2x plus 7 plus 2x squared minus 5, okay? You're just combining like terms. You should have done this. Start with the largest exponential value, 3x squared. Is there an x squared over here? Yes. You can only add like terms. 3x squared and 2x squared make 5x squared. You've got 5x squareds. It's like saying, I have 3 apples plus 2 apples makes 5 apples. You're done with the x squareds. Now we go to the 2x. Is there just an x variable over here? No. Just bring down the positive 2x. You're done with that one. And then you've got a 7, which is just the constant in this problem. There's a -5, a 7 and a -5. It's 7 minus 5. That's a positive 2. You've combined the like terms and written them into this new polynomial, multi-piece nomials here, or monomials here. And you need to remember, if you don't know this already, descending variable order is the key. X squareds, x's, no x's at all. If there's multiple variables in it, then you use alphabetical order to put them in there as well. You'll see that later on with some of the problems that we'll do that have multiple variables. But right now, we're just using single variables, but it's usually descending exponential value. X to the second, x to the first, no x's at all. Okay? Now, another way that you could have done it is just take the pieces and line them up underneath this and make it 2x squared minus 5. And you just line up the parts so that they're one over the top of the other of the pieces. Yeah, that one's blank. That just comes straight down, just like what we did. Okay, making sense? That's combining like terms. Now, what if I change this problem ever so slightly? 3x squared plus 2x plus 7 minus 2x squared minus 5. Be very careful. This is like number 2 in the problem up in the polynomial study guide. Okay? This is like number 2. You've got a minus sign. That negative sign, and I'm hoping you know this negative sign distributes through this expression over here. Okay? It gets distributed through that binomial. Okay? You could write it the way it is. Some people change the negative sign into a plus and change the values inside. I like to look at this as individual parts. I have a 3x squared minus a 2x squared. I'm subtracting 2x squared. What's 3x squared minus 2x squared? It should be just a positive 1x squared. No, you don't need the 1, but I'm just putting it there. Again, there's no x value, so you just bring down the 2x. That works out nice. But now you've got a 7 minus a negative. Minus a negative, people. Minus a negative. That means it's a positive 5. So that means you're adding 5 onto this. Add the 5 onto that, and it's a positive 12. That's your new trinomial when you combine the like terms. Okay? Careful, careful, careful. That's number 1 and number 2. We just went over number 2. Distributing the negative throughout the parentheses. Distributing that negative sign throughout the parentheses is key. Now, distribution. That's like number 3. The distributive property. Okay? The distributive property, let's just say I've got a 5x squared times the quantity of 3x squared plus 2x minus y. Ooh, I'm doing it a little different than what's in the paper, but this is interesting. I've got that goofy y at the end of it. Good news is it doesn't matter what the variables are, what's in front of them, what anything is. It's multiplication. You can multiply exponential values. 5x squared times 3x squared. Coefficients, you just multiply. 5 times 3 is 15. X to the second, add, remember, exponential values, x to the 4th, okay? X squared times x squared makes x to the 4th. 2 plus 2 is 4. Now I take 5x squared and distribute it to the 2x. 5 times 2 is a positive 10. X squared and just an x, which is x to the 1st if there's nothing there, remember that. X to the 2nd and x to the 1st make x to the 3rd. You add the exponential values. Now be very careful with this last one. It's a negative 1 out in front. 5 times a negative 1 is a negative 5. Are there any x squareds to combine that with? No. So it just goes x squared, but bring down the y because you can't get rid of it. It's still there. You just don't add or combine the exponential values because they're not the same exponent. You now have distributed the 5x squared throughout that trinomial, and the coefficients just multiply, add the exponential values if they're common exponents. If there's an extra variable in there, it just comes down. It just is part of it. 5x squared y is the way you'd read it. 5 times x squared times y. Okay, not a touch screen computer. I don't know why I was touching my computer screen to make the light come back on. Okay, that's the distributive property with this. That's like number 3. So we've got the idea. Another way you could have done this, I like the method there. Let me erase again. Hold on, don't go away. Not going anywhere. Let me erase. I like the distributive method for the negative sign as well. Okay, it works out really nicely. So let me make up a problem where I've got, let's say, 5x to the 2nd plus 3x minus 2x to the 2nd minus 4x minus 3. Okay, I like using the distributive method here. I do this. The negative goes to this, it makes it a negative 2x. The negative goes here, it makes it a positive 4. The negative goes to there, it makes it a positive 3. Okay, rewind this and look, because it sort of got cut off when I was talking about it. Distributing the negative recreates this and makes it 5x squared and a negative 2x squared plus 3x. There's a positive 4x plus 3. There's nothing up here, so it just becomes plus 3 down here. And you just go straight down. 3 and nothing makes 3. 3x and 4x make 7x. 5x squared minus 2x squared makes 3x squared. Distributing the negative throughout the parentheses, which will work for number 2, distributing the negative throughout those parentheses, we'll change it from 2x to the third, negative x squared, minus 9. Okay, that's the only help I'll give you on number 2. Now, the FOIL method. I am going to give you a couple of different ways to do the FOIL method. If you were lucky enough to have Miss Tenaskew, she taught me, because I only used the FOIL method for decades. That's all I ever used was the FOIL method to be able to do any type of multiplying of binomials. Okay, that's the only method that I used was the FOIL method. She taught me another way, and it's a really cool way that works with ugly ones like number 7 really very nicely. Let me show you the FOIL method first. FOIL. First, outside, inside, last. It's just an acronym. First, outside, inside, last. So if I've got x plus 3 times the quantity of x plus 1, okay, I use the FOIL method. First, outside, inside, last. Let me use a different color just to give you a better view. First means I take the first number, boop, boop, multiply. 1x times 1x makes 1x squared, or just plain old x squared. That's first. Outside of the two outside numbers. There. Outside. X times 1 is just a positive 1x. Inside, that's the inside two numbers in the binomials. 3 times x is just a positive 3x. And last, x times 1, last, 3 times 1, that's last. It's the last numbers in both of them. 3 times 1 is 3. Not done yet. You've done the distribution. All you're basically doing is distributing the x through, distributing the 3 through. You've got to combine the inside two parts. Now, I will always refer to this, if you've ever had me, or if you know somebody that's had me, I will refer to this as the OI part of the problem, the outside inside. When you multiply the outside, x times 1, and the inside, 3 times x, you've got like terms that you can combine. 1x plus 3x is 4x. You gone. Bring down the plus 3. Bring down the x squared, and that's a positive 4x. You've created a trinomial from multiplying two binomials. Okay? Created a trinomial. Now I'm going to show you a different method for the same problem. Okay? Not quite Miss Tenaskew's yet. Not quite there yet. It's just the distributive method. It's just distributing. X plus 3 times the quantity of x plus 1. I distribute the x. I'm going to distribute this x throughout all of this. X times x is x squared. X times 1 is a positive 1x. Then I'm going to distribute the other part of it. 3 times x is a positive 3x. 3 times 1 is a positive 3. It is the exact same thing as the FOIL method. It's just that they created a name for FOIL, first, outside, inside, last, for the distribution of each part of this problem. First, outside, inside, last. Distribute the x, distribute the x, distribute the 3, distribute the 3. Combine like terms, makes the same answer. Okay? Now, let's show you Ms. Tenaskew's method, which is very similar to anybody that's used the lattice method for multiplication. Okay? You're going to write the first binomial, x, and a positive 3 here. You're going to write the next binomial, x, and a positive 1 there. Okay? Just like the lattice method. X times x is x squared. X times 1 is 1x. 3 times x is 3x. 3 times 1 is 3. And you go diagonally through this. X squared plus 4x, because they're both positive, plus 3 because it's positive. Same stinking answer, different way of doing it. Now, why does this method work well? What if I change this problem ever so slightly? Just a little bit of a change here. Let me erase. Just a tiny change. And instead of it being a binomial for the second part of this, what if it's a trinomial? What if it is, okay, you're back. There you are. What if it's x plus 2 times the quantity of x squared plus 3x plus 7? Now the FOIL method doesn't work. I can't go first out, so there's multiple parts. I can't do it, but I can use Miss Tanaskew's lattice method. Watch carefully. I take the x and the 2. I take the x squared, the 3x, and the 7, and I put it there. X times x is x to the third, because that is an x to the first. X times 3x is 3x to the second. X times 7 is 7x. 2 times x squared is 2x squared. 2 times 3x is 6x. And 2 times 7 is 14. Now just diagonal. That's an x to the third. 3x to the second plus 2x to the second makes a positive 5x to the second. Positive 13x plus 14. Okay, that works really well with number 7, because you've got a trinomial times a trinomial to be able to do that one. Now, I don't care. There are going to be, and I'm going to let you know, there are going to be teachers that say, you have to use the FOIL method. Okay, have to use the FOIL method. It's the only way that you can do this, blah, blah, blah. There are going to be teachers that say, I want you to, I don't give two hoots what method you use. I don't care if you use the FOIL. I don't care if you use the distributive method. I don't care if you use the lattice method. Any one of those methods will service you very, very well. This is all we're going to be doing today. Okay? All we're going to be doing, I want you to focus on just the first page. Numbers 1 through 7. Let me see. Yes, I don't want you to worry about factoring. Factoring will be tomorrow. We're going to worry about factoring mañana, okay? Today, just do adding and subtracting, combining like terms. I like to say combining like terms. I stole that from Mr. Johnson, the 8th grade math teacher. Combining like terms, distribution, FOIL, special case type of FOIL. We're going to talk about those. And then I'd say lattice, the Miss Tanaskew method, but you can use any method to be able to do. If you just distribute the 5x squared throughout, distribute the 3x throughout, negative 3, distribute the 4. Any method. Those are the only ones you're doing, numbers 1 through 7 on this worksheet. I can give you more. I probably will give you more of this later on today. I'll post, you got only 15 minutes left of class today, but I will post more later on, more problems like this, just for you to practice. Okay, especially the special case ones, the perfect square ones, perfect square binomials. You need to start to understand those. We'll spend a little bit of time on this tomorrow, but combining like terms, distribution, FOIL, and then lattice probably. Okay, talk to you later. Have a nice day. It's hot out. Stay hydrated. Bye.